Welcome back to another AP Pre-Calculus video. Today we'll be going over topic 3.13, worksheet A. So this is on trig and polar coordinates. So let's go ahead and get started. So first thing we have here, hopefully you went over the notes, that this right here is a polar graph and it looks something like this, kind of like the unit circle that we've been memorizing, like the entire unit. Basically all these values up here, they basically are the same as the unit circle. And here we have the y values, and the x values are basically based on these circles here that we can see in bold, and tells us here, like this circle right here is 1, this circle right here is 2, this circle right here is 3. And then these lines are the unit circle values that we should have memorized. And in case it is hard for you to memorize, a trick that I have here is that each line, but you do have to add a couple lines. So basically, to use a denominator of 12, which is actually what I do sometimes. Let's say this is 2 pi right here. This is also 0. 2 pi or 0. To put 2 pi with the denominator of 12 would be 24 pi over 12, right? Because 2 pi, and then we want this to be 12, so then we have to multiply the top and bottom by 12, and that gives us this. So then every single line shown here is gonna have a denominator of 12, and we just keep counting up. This is 2 pi, right? But for 0, it would just be 0, right? So this line right here is where 1 is gonna start. 1 is gonna start there. When you memorize a unit circle, however, you don't have like this line and this line because they don't have any values. It's only these 3 values with these 3 lines, right? So you kind of had to like just put those lines in. But for this polar function, it does have it. And so for if I'm counting, this is 1 pi or pi over 12. This is 2 pi over 12. This is 3 pi over 12. This is 4 pi over 12, and so on. And if we simplify these values here, we see we'll get these values. This one right here, if we divide both by 4, that gives us pi over 3. If we divide this value by 3, that's pi over 4. Divide this by 12, top and bottom, that's pi over 6. And that's basically a trick. You can imagine every single line with a denominator of 12. But make sure you are counting these extra lines, because each section only comes with 3 lines that have values to memorize. You do have to add the ones in between on the ends. So yeah, though that's only if you struggle to remember. Yeah, it is pretty hard to remember, so yeah. Anyways, let's get onto it. So this is the start of number 1. So I explained the polar a little bit. So now we're going to plot A, B, C, and D. So A, we have 3. So the x values are going to be based on these circles here, which is also basically the radius, I believe. Coordinates are radius to angle. This right here is angle. It's just, you call it theta because you don't know the angle. And this is the polar coordinates. Here we will talk about turning those polar coordinates into rectangular coordinates, which is just regular xy. But this is polar coordinates, so you know. And the angles are these values we do have to remember. So 3, we start with 3. 3's here, and 2 pi over 3. And using the method of 12s, we can, if we don't know where this is, we can turn the denominator into 12, which is multiplied by 4, so we have to do it on both sides. Times 4, that's 8 pi over 12. And if we count, this is 1. You can count starting from 1, but that's going to take a while, so I like to memorize that this line is 6, this line is 12, this line is 18, this is 1 or 24. So it goes by 6, right? Because 0 plus 6, 6 plus 6 is 12. So yeah, this is 6 right here, then 7, 8. So it looks like 2 pi over 3 is, and our radius was 3, so A must be right here. And I'm going to go ahead and go with a different color for B. So we have this here. You can keep doing the the 12. I guess I'm going to keep doing that, even though some of you guys probably have memorized it. So 6 times 2 gives us 12. So 12, and that's 14 pi. So I know this right here, this line is 12, so it's 12, 13, 14. This right here is 7 pi over 6. 2 is this, so it looks like B is here. You might want to do it quicker, because obviously the AP exam has a time limit. But yeah, so let's go ahead and do C and try to do quick. We can see pi over 4, we already know that. That's here. And 1.5, this is 1, and this is 2. So 1 has to be in the middle, right? So it would be here, because that's approximately the middle. We see we have 1.5 and then 1.5 on both sides. So that is C. And now for D is pi over 2. Hopefully you remember that one. Pi over 2 is here. And then D is on 1. And yeah, pi over 2 is here. So D is here. So yeah, that are those 4 coordinates. I don't know why this line thing is showing. It's just the app I'm using, I guess. Alright, so moving on to the next one. So you also have to learn on these. I can see all of these have negatives. Negative means that you have to reflect 180 degrees, which is basically across. So if I'm over here, reflex goes over there. We're not reflecting like over the x-axis or the y-axis. No, we're reflecting 180. Let's get started with A. We have here -3. So we're looking at 3 for now. We do everything normal except whatever we plot, and then we reflect it. So we have 3 and then 5 pi over 6, which is over here. You can change the denominator to 12, but I remember that 5 pi over 6 is here. And then -3, so then originally A would be here. But then because it's a negative, we do have to reflect. So I'm going to follow this line here to this line here. And that's 11 pi over 6, but we don't need to know that. We just need to know that A is there. So that's A. And now B is also -2. So we're on radius of 2 pi. So it's right here. Right here originally. But then because it's negative, we have to reflect. So it's here. And now C, we have C is also negative. Pi over 3 is right here. -1, because it's a negative, we reflect. So following that line is right here. If you ever lose track of like the line you're tracing, because the denominator is 3, we reflect it. It's a quadrant that is 180 across. It also has to be, the denominator has to be 3 too. So that's C right here. And now D, -3, 7 pi over 4. If we multiply both by 3, that's 21 pi over 12. So this is 18, 19, 20, 21. So 7 pi over 4 is here. It's a -3. So we do reflect. We follow this line. Wow, it is easy to get lost. But it should be here because I know that. Oh wait. This line right here, and this line is the middle of everything, and so I know it is it has a denominator of 4. All right, so now we have negatives for the angles but not the radius, so that just means that instead of going counterclockwise, we're going to be going clockwise, because a normal unit circle, you're going this way. So we have 2, so we're on the second circle here. -pi over 6, so if we're going normally counterclockwise, pi over 6 is here. So we go the same distance but the opposite way. So that was 2 sections, so it should be this line right here. And we're on the second circle, second bolded circle, so A should be here. Now B, we have both negatives. So let's start with, it's 3, don't reflect yet, because we don't know where to reflect yet. And we have -pi over 2. So I know pi over 2 is, positive pi over 2 is here. So if we just do the same thing, but the other way, it's going to be here. So B should be here. But then, because we have a -3, we have to reflect. So we're actually up here. So if you like, I think it might have been another worksheet, but it's like other ways to write that. You could have wrote 3 comma pi over 2. It could have just been that without the negatives. It would have given you the same thing. And now C, we have -2, so we're on the second circle, and then 3 pi over 4. Multiply both by 3 to get the denominator as 12. That's 9 pi over 12. So this is 6, 7, 8, and 9. So 3 pi over 4 should be in this line, this middle line right here. But we have a -2, so we're reflecting here. Keep it as the middle line on quadrant 4. This is the middle line, so we're at -2. So C should be here. And then D, -2 and -2 pi over 3. So 2 pi over 3 normally is here, this second line after pi over 2. So if we go clockwise, it should be the second line to the left of the line reflecting pi over 2, which is 3 pi over 2. So it's this line right here, and we are on 2, but -2, so we're reflecting it here to pi over 3. So 2, so D is here. And that is number 3. So moving on to number 4. We're starting with these questions where we want to show other ways that we can write this polar coordinate here without using the polar graphs. So here we have this. Other ways to write it, obviously we could change both of them, add like 2 pi to this, because it would to this value right here, it would be the same thing, because like let's say draw that graph, right, you end up with this line. But if you add 2 pi, that's basically just adding 1. You'd end up at the same place. We can add 2 pi to 5 pi over 6, and so we have to multiply both by 6. That would give us 12. 2 times 6 is 12. 6, that gives us 17 pi over 6. So another way to write it is 4 comma 17 pi over 6. All right, but we can also like put a negative on one of these, right? So we want a reflection of this. So I'm actually going to go to the polar coordinate so you can understand what I'm saying. So if we put a negative on the 4, right, it has to reflect. So let's look at 5 pi over 6, which is this line right here. It's 4, so it's like right here. But yeah, I'm going to just say it's 3, okay? Just pretend like it's 3 for now. The reflection of that line is right here. Whatever I'm about to do, I want it to be here, because the -4 is gonna make it reflect to here, because we want it to end up here. So it's the same thing as here. You could say that's negative pi over 6 or 11 pi over 6. So that's actually 2 more ways to write it. So that's 2 other ways to write it. And you could also write it the other one I just said, or you can also write it as only the second number as a negative. That's -7 pi over 6. All right, so here we have this one right here. We can add 2 pi to that. That's always the easiest in my opinion. So multiply by 2. Oh wait, sorry. Multiply by 4. So that gives us 8 pi over 4. And that's 13 pi over 4. So we have -13 pi over 4. So like we did on the other equation, instead of looking at the polar graph, we can just do subtraction. So because we know it's reflecting, or reflection is just 180, and 180 is pi. So technically, using the original, we can actually just subtract or add pi. But if we do that, we do have to change the sign if it's negative or positive. So we can add pi on the other one. So 5 pi over 4, that's a 4. Or sorry, not add, subtract pi. And so multiply both by 4. That gives us pi over 4. So because we added pi there, That means that the 3 is going to be positive now. So yeah, if we add or subtract pi, it will change the sign of the first one. And pi over 4. So yeah, pi over 4 is basically a reflection of 5 pi over 4. So these two work. You could have also written -3 pi over 4, or 9 pi over 4, which is adding pi, and this one right here was subtracting 2 pi. Here we have another one. We can just do the same math. 3 pi over 2 plus 2 pi. So this changes to 4. 7 pi over 2. We could also subtract 2 pi. We can also work with pi, so add or subtract pi. So our first coordinate we can put as 2, 7 pi over 2. And now I'm going to subtract pi, but make sure that I change the sign of the first number or the radius, because working with pi means reflecting. 3 pi over 2 minus pi. Multiply 2 top and bottom, and that gives me pi over 2. And so -2 pi over 2. Those are the two answers that I got. But you could have also gotten 2, negative pi over 2, or -2, 5 pi over 2. Now we're moving on to multiple choice questions. This is the same logic here, so we're finding which coordinate is the same as this one. 4 pi over 3. We can already tell it's not this one right here. Whoa, that got big. We can already tell it's not B because it has the same angle, but it's reflecting, so that's different. We can add, and we can do the math with 2 pi and pi. So 4 pi over 3 plus 2 pi. We can plus, but we can't guarantee that. It's going to be in one of the answer choices. Common denominator would be 6, so this turns into 8. That's 6, 12, 6. That's 20 pi over 6, which simplifies. Both of them can be divided by 2, so 10 pi over 3. That's not in any of them. 4 pi over 3 subtracted by pi is equal to pi over 3. So we just have pi over 3 here, but it should be -5, pi over 3. If we have negative pi over 3, that's just super random. The only coordinate that will work with pi over 3 is going to be -pi over 3. Nothing else will correspond to pi over 3. If we add pi, it's not going to give us pi over 3, it's going to give us something else. So it's not D. And actually, if we look at A, it has the same number of this, right? Which is automatically not a reflection of 180 because we see this is negative. It should be a reflection of 180, but it's not. The same number would just be a reflection over the x-axis, actually. So it's not A, therefore it's C. You could keep doing the math and like add pi or subtract 2 pi, but it's that. Now here we have another one. This one reflects, so it actually ends up being 3 pi over 2. So if we just look at this one right here reflects over 3 pi over 2. So this one will land at pi over 2, so it's not A. This one right here is just at pi over 2. We can automatically know that B is not an answer since this reflects and has this, they both have the same angle. C has -3 pi over 2. So if we think about it, 3 pi over 2 is there, so if we're going the other way, it ends up, so we didn't really do any math there, but yeah, it is a little easier if you memorize like the main parts of the unit circle and quadrant 1. Memorizing quadrant 1 will help you memorize the rest. Now we have here 5 pi over 6, which is in quadrant 2. We automatically know it's not A. it's a positive instead of a negative, but has the same values for both. B, it wouldn't be B because 7 pi over 6 is literally a couple lines below. That was just because I memorized it, but you could multiply it for a denominator of 12. C could be C, so if let's try adding pi or subtracting pi, because the value changed there to positive, so we can do both. Let's subtract pi. That gives us pi over 6, but then we can also add pi. So you could 11 pi over 6. So it looks like C is our answer. D here, the value changed for pi is 5 pi over 6, but kept the same value for R, so that's wrong. And so it's C. Now we're moving on to different kinds of problems, changing from rectangular to polar, or polar to rectangular. In this case, this one is polar to rectangular. So you have to memorize how to do this. For polar to rectangular, we need to find x and y. So we have to set each of them to x is equal to, so x is always cosine, y is always sine. So basically it's r cosine or sine, whatever you do, and then the angle there, and then you solve for the x or y based on if you put cosine or sine here, that'll be x or y. So x is cosine, so r, the radius is 2 cosine, and then the angle or theta, and then on the other side for y would be the same thing but sine, and then we're just solving for x and y. So that's pretty simple. So that's going to give us, you do have to think about the unit circle here, 5 pi over 3, that's 1/2. That's the coordinate for 5 pi over 3. 5 pi over 3 times 4, both sides, so we can get 12 as a denominator. That's 20 pi over 12, which is in quadrant 4. And if we remember, pi over 3's, every pi over 3's would have 1/2 as x and pi over 3 over 2 as the y value, but the only thing that changes is the charge, positive or negative. And because we're in quadrant 4, the only negative is y. So cosine is x, so that's 1/2. So x is 1, and y is going to give 2 sine of that. What's this? That's sine, so don't forget the negative sign. That's going to give us, you just multiply, so the 2's cancel out, so negative square root of 3. Our answer is C. 11 does the same thing, polar to rectangular, so we just do that there. X is equal to 1 cosine 2 pi over 3. 2 pi over 3 times 4, that's 8 pi over 12. So that's in quadrant 2. You still have pi over 3, so 1/2 square root of 3 over 2. Because we're in quadrant 2, what is only the x value is negative, so that's negative there. So 1 over negative 1/2. So x is equal to negative 1/2, and then we have y is equal to 1 cosine. Same thing. Oh, sorry, I wrote cosine. So 1 sine square root of 3 over 2. So y is equal to square root of 3 over 2. So we find that here. Both negative, that's negative. Looks like it's C again. Alright, so same thing here. Pi over 3, we already know pi over 3. Both are positive. So, like I said, just memorize everything in quadrant 1 and use the denominator of 12 trick, and you got it. And so x is equal to negative 4 cosine. We can write the same thing for y, except switches to sine. So back to x, negative 4. The cosine is 1/2, so that's going to give us negative 2. And then y, that's negative 4 square root of 3 over 2. That's going to 4 divided by 2 is going to give us negative 2. Negative 2 square root of 3. So it looks like our answer has both negatives, so it's C. Now we have negative pi over 6, which is 11 pi over 6. And pi over 6s, they always look like this. But because I know it's in the quadrant 4, y value will be negative. So x is equal to negative 1 cosine of negative pi over 6. And y is equal to negative 1 sine of negative pi over 6. So that's negative 1 cosine, that's that. And that gives me negative square root of 3 over 2. And for the y is negative 1 times negative 1/2. And that gives me positive 1/2. And so should be B. Alright, now moving on. Now we're changing from rectangular to polar. So this one, rectangular to polar, in my opinion, is a little more work. So yeah, so we have the x and y values. Now we want to change it to radius and change it to angle. So to change it to radius, we need to, that's an r. R is equal to the square root of x squared, that's 3, plus y squared. Pretty sure this is a distance formula, so you're basically finding the distance. So it's the radius. So that's 9 plus 0, which is square root of 9, which r is equal to 3. So now we want to find the angle here, and by finding the angle, we're finding the tangent. So tangent of the angle of theta. So theta is what we're trying to solve for, right? And we're going to be using tangent. So that's going to equal to, what tangent is y over x. So that's 0 over 3, which is equal to 0. So tangent of theta is equal to 0. So we know two coordinates that tangent can be 0. That would be where it's 0 divided by 1 or 0 divided by negative 1. So that means that it's 1 comma 0 or negative 1 comma 0. This, we know that one is 0, and this one is pi. All of these answer choices don't have 0, so it's not going to be 0. We're going to be using pi, so looks like we're going to be using 3 and pi. But if we look back at the radius, I actually did do one mistake. When we square root a number, every time we square root a number, we need to make sure we're adding plus or minus. So after we square root a number, it's always plus or minus. So plus or minus 3, right? But because it's plus or minus, one is reflecting and the other one is not. So one of these values must have a reflection and the other one it doesn't have a reflection. So first of all, we can cross off A and cross off D. It's one of these two. We can look back at the rectangular to look back at what the original one would be. The original was just 3, 0. That's with no reflection, so that's a positive 3. So if we do reflect, it's negative 3, pi, so it should be C. Now 15 is the same thing. So r is equal to the square root of, wow, these numbers, negative. Alright, so that's square root of 1/4 plus 3 over 4. And if we add that on the inside, that's 4 over 4. So it's basically the square root of 4 over 4. Hopefully, that's not like a little messy. Sorry about that. So that's just 1. So square root of 1. So r is equal to plus or minus 1. And now if we solve for the angle here, tangent is equal to y over x, right? And so we just multiply with the reciprocal, so I'm actually going to delete that. So we multiply the reciprocal, which is negative 2, so 2 that, so we can cross out that, so it's equal to negative square root of 3, so tangent of theta is equal to negative square root of 3, and we know that coordinates that look like this would give us square root of 3. You basically just have to so it's, because I know it's either going to be this coordinate or square root of 3 over 2 comma 1/2. You just kind of have to just test it. Yeah, so square root of 3 over 2 times the second number, which turns into reciprocal. 2's at the top, 2's at the bottom, so they cancel out, so that gives us square root of 3. But we know it's a negative, so it's either negative with the x or negative on the y. And from there, we can check with the rectangular coordinate. We see that it's negative on the x, so we know it's going to be negative on the x here. So because negative x, that should be quadrant 2. Coordinates like that have it's pi over 3. So that should be 2 pi over 3. 2 pi over 3. So the only one with 2 pi over 3 is C. Now let's do the same thing here. When you see you have the square root and square, you can basically just cross that out. So it's just going to be 2. Because it's a negative, that's just positive on both too. So it's 2 plus 2, which is 4. So square root of 4, that gives us r is equal to plus or minus 2. So now moving on to tangent, that's just negative square root of 2 over negative square root of 2, which is equal to 1. So where's tangent equal to 1? That would be coordinates that look like that. But we have both negatives there, so negative and negative, they're both negative. That would be quadrant 3. Quadrant 3, everything's negative. Coordinates that, or the angle that looks like that have these coordinates are pi over 4. So which value is on pi over, or quadrant 3, it should be, if we check here, so times 3 here, that's 15 pi over 12, which is on quadrant 3. So 7 pi over 4 is quadrant 4. If we check, that's 21 pi over 12. So yeah, so it's either A or D, so we'll cross off B and D. Or sorry, it's either A or C. So let me write this real quick. So it's 5 pi over 4. It's 5 pi over 4 normally, because 5 pi over 4 is already in quadrant 3. We know our polar coordinate should be in quadrant 3. If we reflect, it's going to end up in quadrant 1, so we don't want it to reflect. So it's not C, so it's A. So now we're moving on to complex numbers here. It looks a little difficult, but all you have to know is that the number here on the outside is the R value. And the number inside the parentheses, or, you know, to the what we're finding with the trigs, are the angle here. So this is R and the angle is there. So you just have to remember that. So because we're given a rectangular, we need to find the polar coordinates so we know where and what is where. We need to change that to polar. So that's just 4 plus 4, which is square root of 8. Simplify that. That R is equal to plus or minus 2 times the square root of 2. And then we find tangent negative 2 over 2, which is equal to negative 1. So where's tangent negative 1? That should be, this coordinate gives it 1, right? So we don't know which one's negative, but if we look back at the rectangular, y is negative, so that right there is negative. Negative y corresponds to quadrant 4. We know this is over pi, so it's 7 pi over 4. Yeah, 7 pi over 4 is also equivalent to negative pi over 4. So, because all I see is pi over 4 here. There's no 7 pi over 4, so it has to be negative of pi over 4. So we already can cross off A and B because they have positive pi over 4. Our R is 2 times square root of 2, so it's C. Now here is the same thing, so let's go ahead and do that. And that's just equal to 1, so R is equal to plus or minus 1. And now the tangent, negative 1/2 divided by x. So we can just multiply the reciprocal of x. That gives us positive. So it's just that, but we need to, don't want it to, because we're not like ending our answer with square root of 3. It doesn't really matter, but If you don't like to see a radical at the bottom, you can obviously change it. But changing it would give us that. Because we multiply both by the square root of 3. So it's the same thing. Where's tangent equal to that? It should look like this. Because then we always do the reciprocal of x. So square root of 3 is at the bottom. And square root of 3 is at the bottom. So it looks like that. But we have negative on both. So that's quadrant 3. Coordinates like that is pi over 6. So quadrant 3 of pi over 6 is 7 pi over 6. And, you can change it to 12. That's times 2. That's 14. 12, 13, 14. That's a reflection of pi over 6, actually. So, yeah. So 7 pi over 6 is equal to the angle and 1. So it looks like it's B. Oof, we barely have any space to do anything here. So we're given this right here. So if we look into here, these are the polar. That's the polar coordinate right there. Sorry, it's not negative. That is the polar coordinate. So we just change it to rectangular. To cosine. That's gonna give us 2 something. So I'm gonna over here write what the coordinate of negative pi over 3 is. Negative pi over 3 should be quadrant 4. So pi over 3s, they look like they start with 1/2. Because it's quadrant 4, the y value is negative. So that's what the coordinate looks like for negative pi over 3. So cosine is 1/2 x. So x is equal to 1. Then we have y. 2 times negative square root of 3 over 2. That should be negative square root of 3 is equal to y. So it looks like our answer is B. Now the last one, I'm gonna show my work down here, I guess. Yeah, hopefully that doesn't confuse you, but yeah. That's the polar coordinate. 5 pi over 4. If we multiply both by 3, top and bottom, that's 15 pi over 4, so 12, 13. Remember, 13 is actually not anything since we need to remember to add those lines. So 12, 13, 14, 15. So 15 is a pi over 4. So yeah. So it's quadrant 3 and it's a pi over 4. We know pi over 4s look like this. And quadrant 3 have both negative. So that's what our coordinates should look like for 5 pi over 4. So if we do both x and y, so 10 cosine of 5 pi over 4, that gives us 10 times that, which gives us 5, since 10 divided by 2 is 5. So I'm just like simplifying it already. So that should be x, and then y is equal to 10 sine of 5 pi over 4. So 10 times the same thing. So it should be the same thing. And it is still negative 2, so negative 5 times square root of 2, so they're both negative, so our answer should be A. And that was topic 3.13. So hopefully that helped, and thank you so much for watching, and good luck.